The idea is like this. So imagine we look at a familiar object, just a candle and a holder, and imagine that we want to figure out what it is made of. So we go on a journey deep inside the object and examine the constituents. So deep inside, we all know you go sufficiently far down, you have atoms. We also all know that atoms are not the end of the story. They have little electrons that swarm around a central nucleus with neutrons and protons. Even the neutrons and protons have smaller particles inside of them, known as quarks. That is where conventional ideas stop. Here is the new idea of string theory. Deep inside any of these particles, there is something else. The something else is this dancing filament of energy. It looks like a vibrating string. That's where the idea of string theory comes from. And just like the vibrating strings that you just saw in a cello can vibrate in different patterns, these can also vibrate in different patterns. They don't produce different musical notes. Rather, they produce the different particles making up the world around us. So if these ideas are correct, this is what the ultramicroscopic landscape of the universe looks like. It's built up of a huge number of these little tiny filaments of vibrating energy, vibrating in different frequencies. The different frequencies produce the different particles. The different particles are responsible for all the richness in the world around us. And there you see unification, because matter particles, electrons and quarks, radiation particles, photons, gravitons, are all built up from one entity. So matter and the forces of nature all are put together under the rubric of vibrating strings, and that's what we mean by a unified theory. Now here is the catch. When you study the mathematics of string theory, you find that it doesn't work in a universe that just has 3 dimensions of space. It doesn't work in a universe with 4 dimensions of space, nor 5 nor 6. Finally, you can study the equations and show that it works only in a universe that has 10 dimensions of space and 1 dimension of time. It leads us right back to this idea of Kaluza and Klein that our world, when appropriately described, has more dimensions than the ones that we see. Now, you might think about that and say, well, okay, you know, if you have extra dimensions and they're really tightly curled up, yeah, perhaps we won't see them if they're small enough, but, you know, if there's a little tiny civilization of green people walking around down there, you make them small enough and we won't see them either. That is true. One of the other predictions of string theory. No, that's not one of the other predictions of string theory. But it raises the question, are we just trying to hide away these extra dimensions, or do they tell us something about the world? And in the remaining time, I'd like to tell you 2 features of them. First is, many of us believe that these extra dimensions hold the answer to what perhaps is the deepest question in theoretical physics, theoretical science. And that question is this. When we look around the world, as scientists have done for the last 100 years, there appear to be about 20 numbers that really describe our universe. These are numbers like the mass of the particles, like electrons and quarks, the strength of gravity, the strength of the electromagnetic force. A list of about 20 numbers that have been measured with incredible precision, but nobody has an explanation for why the numbers have the particular values that they do. Now, does string theory often answer? Not yet. But we believe the answer for why those numbers have the values they do may rely on the form of the extra dimensions. And the wonderful thing is, if those numbers had any other values than the known ones, the universe as we know it wouldn't exist. This is a deep question. Why are those numbers so finely tuned to allow stars to shine and planets to form when we recognize that if you fiddle with those numbers, if I had 20 dials up here and I let you come up and fiddle with those numbers, almost any fiddling makes the universe disappear. So can we explain those 20 numbers? And string theory suggests that those 20 numbers have to do with the extra dimensions. Let me show you how. So when we talk about the extra dimensions in string theory, it's not one extra dimension, as in the older ideas of Kaluza and Klein. This is what string theory says about the extra dimensions. They have a very rich intertwined geometry. This is an example of something known as a Calabi-Yau shape. Name isn't all that important, but as you can see, the extra dimensions fold in on themselves and intertwine in a very interesting shape, interesting structure. And the idea is that if this is what the extra dimensions look like, then the microscopic landscape of our universe all around us would look like this on the tiniest of scales. When you swing your hand, you'd be moving around these extra dimensions over and over again, but they're so small that we wouldn't know it. So what is the physical implication, though, relevant to those 20 numbers? Consider this. If you look at the instrument, a French horn, notice that the vibrations of the air streams are affected by the shape of the instrument. Now, in string theory, all the numbers are reflections of the way strings can vibrate. So just as those air streams are affected by the twists and turns in the instrument, strings themselves will be affected by the vibrational patterns and the geometry within which they are moving. So let me bring some strings into the story. And if you watch these little fellas vibrating around, they'll be here in a second right there, notice that the way they vibrate is affected by the geometry of the extra dimensions. So if we knew exactly what the extra dimensions look like, we don't yet, but if we did, we should be able to calculate the allowed notes, the allowed vibrational patterns. And if we could calculate the allowed vibrational patterns, we should be able to calculate those 20 numbers. And if the answer that we get from our calculations agrees with the values of those numbers that have been determined through detailed and precise experimentation, this in many ways would be the first fundamental explanation for why the structure of the universe is the way it is. Now, the second issue that I want to finish up with is, how might we test for these extra dimensions more directly? Is this just an interesting mathematical structure that might be able to explain some previously unexplained features of the world, or can we actually test for these extra dimensions? And we think, this is, I think, very exciting, that in the next 5 years or so, we may be able to test for the existence of these extra dimensions. Here's how it goes. In CERN, Geneva, Switzerland, a machine is being built called the Large Hadron Collider. It's a machine that will send particles around a tunnel, opposite directions, near the speed of light. Every so often, those particles will be aimed at each other, so there's a head-on collision. The hope is that if the collision has enough energy, it may eject some of the debris from the collision from our dimensions, forcing it to enter into the other dimensions. How would we know it? Well, we'll measure the amount of energy after the collision, compare it to the amount of energy before, and if there's less energy after the collision than before, this will be evidence that the energy has drifted away, and if it drifts away in the right pattern that we can calculate, this will be evidence that the extra dimensions are there. Let me show you that idea visually. So imagine we have a certain kind of particle. It's called a graviton. That's the kind of debris we expect to be ejected out if the extra dimensions are real. But here's how the experiment will go. You take these particles, you slam them together, and if we are right, some of the energy of that collision will go into debris that flies off into these extra dimensions. So this is the kind of experiment that we'll be looking at in the next 5, 7 to 10 years or so. And if this experiment bears fruit, if we see that kind of particle ejected by noticing that there's less energy in our dimensions than when we began, this will show that the extra dimensions are real. And to me, this is a really remarkable story and a remarkable opportunity. Going back to Newton, with absolute space, didn't provide anything but an arena, a stage in which the events of the universe take place. Einstein comes along and says, well, space and time can warp and curve. That's what gravity is. And now, string theory comes along and says, yes, gravity, quantum mechanics, electromagnetism, all together in one package, but only if the universe has more dimensions than the ones that we see. And this is an experiment that may test for them in our lifetime. Amazing possibility. Thank you very much.
That's absolutely fantastic.